Thank you, everyone. Thanks for joining. This is the third class, week number 2. First and foremost, shout out to those who attempted the last project, or if you like, the last week task. If you've picked up a thing or two, we continue to encourage you to give it a shot. That's the best way to learn. Usually we would always talk about stuff in class and discuss this and that, but ultimately it will come down to you practicing, getting your hands dirty and learning on your own. Obviously, if you have any questions, you can always come check on the channel, ask questions back and forth. That's the only proven way to learn. So we're gonna continue on our sort of journey, and sort of one piece at a time. So today I want to go a bit over the cloud platforms a little bit one more time, and then sort of zoom in on the popular cloud model, which centers around infrastructure as service, platform as service, and software as a service. So that's where we kind of gonna play around the space we're gonna play around this weekend. We're going to look at examples of, infrastructure as service, platform as service, and software as service, why we would need them, and in what form they kind of manifest. So we're going to go take a step back, look at cloud, and then kind of zoom in on these three models. So, by the way, before we go ahead, does anyone have any questions, comments regarding what we've done so far, or maybe the product the last task, task number 1. Obviously, if there are none, I'm happy to move ahead. Thank you. So today we're gonna look at a review of main cloud providers. Who are those main players? Their market position. This matters because you want to see how statistically, where does it make sense to pitch your tent, in the sense of what are those cloud platforms you probably need to spend a bit more time on, because there's so many sort of cloud providers around. So which ones are the most common, and where should you pitch your tent to give yourself a good chance of maybe getting a role or doing something that the market really needs. So we're going to look at their respective key services, and then we look at the cloud model offerings. So these are the key players as far as cloud is concerned. So I'm sure most of these will not be new to you. Microsoft Azure is one of the top cloud providers. AWS, I think they are the first and still the leader. We have Oracle Cloud, sort of getting traction in the last few months, and Google Cloud. So in terms of, we're going to see what their sort of market share looks like. But in terms of cloud provider, these are the big ones. So it will be AWS, Microsoft Azure, Google, Oracle, Salesforce, IBM, Alibaba, Tencent. The Alibaba and Tencent, they are not terribly common because of the fact that they are sort of Chinese owned. Um, because of political reasons, people don't really go on the Chinese platform as such. But they are serious players, whereas at least outside of the if you like, the West. So as far as China and East Asia is concerned, these are really big players, Alibaba, Tencent. But generally, this is what the cloud space looks like in terms of market share. So AWS is about 31%. Microsoft Azure is about 24%. Google Cloud is about 11%, and so forth. This would have changed recently because Oracle sort of signing a deal with SoftBank and OpenAI to kind of run their AI platform would have given Oracle a big of a bigger share than 2%. So I would think Oracle over the next few months and years will begin to eat into that space and probably begin to catch up with Google Cloud because of the massive expansion that they are currently embarking on. But in terms of sort of, pitching your tent and where to kind of focus your strength, because the problem is this platform, they are almost like the same, but the way they work, they offer something similar in terms of the general services they provide. But in terms of the engineering that requires to understand them, it differs a little bit. And if you have to, you will have to choose your battles because you can't spread yourself thin to kind of learn each of the cloud platform. So this just sort of gives you an idea as to potentially the what the market what the market share looks like and the probability of getting the job. Say you go and measure yourself as an IBM cloud engineer now, the number of job that will be available to you to do that you can potentially apply for will be very limited as compared to maybe Google Cloud or Microsoft Azure or AWS. But this is sort of giving you an idea as to potentially where you should pitch your tent and where you should focus your strength. So I'll say the first three, you can't go wrong picking one or two there. So if you say you want to focus or major on Microsoft Azure, yep, more powers to you. I don't think you do any wrong doing that because there are lots of jobs out there requesting for Microsoft Azure engineers, and the same for Google Cloud and obviously for AWS. So beyond these three, I think you are kind of in a very interesting area. So I would say focus should be on the first three. So if you can do two of the three or one of the three, that would be great. I'm just going to quickly chip it in here that I will begin to maybe from next week encourage guys to begin to in parallel begin to prepare for their cloud certifications, especially those are interested in actually getting the DevOps role because some people are here just to obviously just sharpen their skill set to learn, not necessarily looking for DevOps role. But if you are the type that's looking to switch into DevOps position, I may have some news for you next week in terms of getting started on your certification regime. I think the sooner you start, the better, so that we can work with you in parallel because we will not be offering this in class, but something that we can assist you in a limited fashion in parallel, just to make sure you cover that area. Okay. If we zoom in a bit on AWS, just to kind of get some facts out, it was launched in 2006, Google Cloud in 2008, and Microsoft Azure in 2010. I think the reason why Azure has sort of gained ground, Microsoft, is because Microsoft has been a player in the enterprise world. Enterprises, organization using software. That's why enterprises. Microsoft have been around a long time, with your maybe Microsoft Exchange, Active Directory, and all the rest of it. They've been around. Maybe they didn't start the cloud journey as quickly as AWS or Google Cloud, but they've been in the enterprise. So when they started offering their cloud platform, which is the Microsoft Azure, it was very, very relatively easy for them to convince their customers to move to their cloud platform because they already have them in their ecosystem. It was just a case of, entrusting your services and infrastructure into a trusted figure such as Microsoft. So it wasn't really too hard. Someone's asking a question. Fantastic, Cynthia. So Cynthia just dropped an interesting stats there. Fantastic. So it wasn't really too hard for Microsoft to convince their customers to use their platform. And as of 2010, a lot of enterprise had not been moving to cloud. So it was Microsoft kind of, leveraged the fact that they already have most of these enterprise within their ecosystem. So that's why even though they're not the first or the second to get the cloud journey running, but they're able to get a lot of sort of enterprise on their platform, um, even sort of beating Google Cloud in the process. So the breadth of services you will get on cloud is computing, storage, analytics, machine learning, AI, and all the rest of it. If you recall many years ago, some might not know this, before cloud came, every enterprise we used to have a data center within the office premise. So I used to work back in the day for a company called MTN in Nigeria. So we had a huge data center in Ojota, huge. So if you go down, it's almost like a car park. It's really huge. And you have huge machines just spinning in a very cold room. And that's what a data center look like, which we call the on-premise data center. So many companies have versions of this where they're going to have what we call a server room, where they will probably run their Exchange server and some machines that are not your normal PCs, but they call them servers that you want to sit in the server room. That was how things used to operate back in the day until everyone started moving things to the cloud. So the cloud is now where you would keep things you probably before then would keep in your server room. Cloud is not a new platform where those things are. So you would hardly see companies having server rooms these days. I think the reason, which I'm going to talk about, it's not far-fetched. So let's go. So, but the rise of cloud computing. So with cloud computing service, so guess let's see here. The point here is the main reason why folks move to the cloud is mainly because it was hard to say, for example, you are um, a marketing company. Maybe you just help people marketing, and you go on out to do jingles, leaflets, and you just help company to market their product. Back in the day, you would need to have serious engineers that would help you in terms of managing your emails, managing your servers, managing your Active Directory, and all the rest of it. So a bulk of your task a bulk of the task will be in managing those machines. Even though you are a marketing company, unfortunately, you will have to somehow get your hands dirty into the tech business. You will need to have a server room. You will need to have air conditioning. You need to bring a lot of machines. You need to buy machines. You need to rack them. You need to wire them. You need to bring in, network engineers to do all the network configurations and wiring for you. It was huge. So invariably, bulk of your strength, bulk of the time that you're meant to use to focus on you just doing what you know best, which is helping companies to market their product. The bulk of your time will be used on entertaining machines, servers installations, server setup, and all the rest of it, which wasn't great. So companies could not focus on their core strength or the service that they wanted to do, but they are kind of dragged into the IT world of, hardware, server room, etc. That wasn't really great for business because they couldn't focus on their core business. And also because you will need to kind of plan ahead. Say you have a company that has maybe about 10, 20 people working for you. The number of machines you will have will be different to if you were having 500, 600, 700 people. If you are scaling, say you want to scale from maybe 10 employees to like 30 employees or to 50 employees, you will have to plan ahead of time so that you can order the right machines and the right artifact that will go in helping you set up the machines if you were running things on premise back in the day. Because one machine would probably not be enough to support 10, 20, 30, 40 employees. So this means you couldn't scale quickly. You will have to order for machines, you have to wait for time for the engineers to come in to help you rack things up, set things up, etc. And also you weren't really sure how good these engineers are in making sure that the thing they set up work the way they should be. So it was quite a bit of a headache back in the day. But with cloud coming now, there's really no need to have a server room because everything you need to do can be easily done on a cloud with a click of a button. That helps you because you can scale fast. You can go from one machine to 10 machines just by a click of a button. Something that probably will take you months will now take you minutes because you just need to have a few clicks and you set up what you want to set up on the cloud and things begin to work. This supposed to, you ordering for machines, waiting for them to be delivered at maybe the port, and then you go clear them, and then you bring them to the office, and you have to rack them, wire them, set them up, test it. It's you can't compare. So you are going from minutes. What used to take you months, what used to take months now happening in minutes, and that is the turnaround for business. Also the cost. So because you can basically configure or ask for what you need on the cloud platform, you can basically limit how much you're going to be spending. So but instead of buying a huge server and worrying about air conditioning, worrying about power consumption and all the rest of it, with cloud, you don't have to worry about that. And also with cloud, you can basically just take what you need, and when you don't need them, you can just delete them and off you go, which is obviously not possible if you were running like a data center within your organization. So agility is part of what you get with cloud, efficiency and innovation. So that is why cloud has become quite popular. So when you're talking about cloud, let me show us a few things before we kind of go away from here. So obviously we know that we've got AWS as a cloud provider. Let's see that. So we played with this a little bit. Let me see. Let's go here. All services. These are A to Z of services that you could have on AWS, quite a lot. And you can go on here, and this is part of like subgrouping. If you want to go service by service, it's a lot. And then you can go and basically select what you want to use, and off you go. This is AWS platform. I think I can log on to my Azure platform as well. Let me see. Let me authenticate. I believe I exist an account. So this is Microsoft Azure platform. Then maybe we can look at Google Cloud at some point as well. Let's take this out. Let's take this out. Let's take this out. And you can also look at the services in terms of what they offer. They're always similar to what AWS were, but they will call them different names. So it's a matter of working out, what service correspond to what here. But it's not like because AWS, you're easily just gonna, plug and play with Azure. You will have to adapt a little bit to be able to use it, but you will not be it will not be a fish out of water. It will just be a matter of basically understanding what's it called, the semantics in AWS and what stands for what, which we are going to look at as we kind of go along. So they're all similar. You can, if you want to set up your Azure platform, I think you already do as well. And some of you already have access, so you can just have a poke around and look at the similarities. So as we go along, we will see some of these similarities. So cloud service models. So we have this is how does a cloud platform provide the services that we need? In what forms does it provide those services? What do I mean? So let's take a step back, okay? So we go back here. So let's say for AWS, we look at all services. And one thing we have played with, let's see. Look at all services we have. These services, they come in different shapes and sizes. And there's no one that knows everything on here, trust me. But you can largely group these services into three groups. You can group them as infrastructure as service, platform as service, and software as service. And why does this matter? And these are the things we will explore in the next few minutes. But this is not only specific to AWS, it's across the board on for all the cloud providers, either AWS, Azure, Google, Oracle, name it. You can always categorize their offering to IaaS, PaaS, or SaaS. Infrastructure as service, platform as service, software as service. So what are we talking about? Okay, so infrastructure as service is a way a cloud platform provide the bare nitty-gritty of machine offerings to an enterprise or a user. What do I mean? When I say machine, generally when we talk about machine, we talk about compute, which is your processors, your storage, and your networking. So if that is what you're after as a company or as a person or as an organization, you'll probably be going for a service model called infrastructure as service. Because what you need is just a running machine. This will be applicable to people who are already familiar with computer. Bear in mind, the cloud, the people that use the cloud, you don't necessarily have to be an engineer. Someone who is not too vast in writing code could use the cloud. So, but the type of things you will look for in the cloud will differ depending on your knowledge or your expertise. Maybe as an engineer, maybe as an end user, maybe someone that just stands in the middle. For example, you could have one Mrs. Edema, who is not a developer, who is not a DevOps person, but who is familiar with Yahoo, who is familiar with Chrome, who is familiar with basic computer usage. And say, okay, they talk about AWS, let me go check it out. And she logs on, she creates an account. And then she might look for a specific service on the AWS platform that meets her need. That is possible. Obviously, because she doesn't understand the nitty-gritty of computing, so she will probably play in the SaaS world, which we're going to come to, but she probably won't be using a service or solution that within the infrastructure service space. When you're talking about infrastructure service, just to simplify it, you're talking about compute. So things that has to do with hardware, networking, and storage. So you would not be dealing with application as such, but you'll be dealing with mostly just VMs and storage. I'm going to explain this a little bit further. So let's just take it for now that infrastructure service, you're going to be managing hardware, networking, storage, and compute. Platform as a service, you will be managing applications that sort of run on IaaS. So this is always the foundation model. This is almost like, say you are building a house, yeah? The first thing that you do in building a house is to lay the foundation. So the foundation, as far as cloud is concerned, is IaaS. Everything is based on IaaS, which is virtual service. The platform as service sits on top of infrastructure as service because you can begin to build platform on your infrastructure. Okay, so this would mean that, say for example, infrastructure as service, you may be setting up machines, which is just an operating system, a VM that is running and not doing anything. If we take that as an example of infrastructure as service, the platform as service will then come and begin to install certain applications or certain software on it, on your infrastructure as service. And the software service will then eventually come where everything on the platform is configured, primed, and good to go. What that means is that with software as a service, it's almost like a turnkey solution. So anybody that is using software as a service comes in and we just begin to use what it needs to use. I'm going to shed more light. I know it might not be too clear now, but just bear with me. But for now, take it that this is the foundation model. PaaS sit on IaaS and SaaS sit on PaaS. A typical user who doesn't know how to use the system will probably operate in this world. It doesn't mean that people that know to use the system will not operate here, but here is the easy part. Um it's like some people that know how to build a car can maybe, let's just say for example, if you know how to build a car, you can go and order for parts here and there and say, okay, I would get some steel, I'm going to weld them together, I'm going to get some rubber, I'm going to make some tires. So the rubbers and tires and steel are here. So if you're a top engineer, you don't need to go and buy BWM engine because you can build your own here. Okay, that's infrastructure service. You're just getting metals, you're getting rubbers, and you are making steel, you are making tires, you are making seats here. PaaS is okay, you have the rubbers and you make the tires, you're making everything. You can then begin to sell tires, steerings, and people can say, okay, I need your tire, I need your steering. I'm going to begin to couple them together. So these are couplers. PaaS are couplers who are leveraging on the things that you have built here. The PaaS guys probably don't understand how to weld steel together, but they can join steerings to crankshaft. The crankshaft has been built here, the steering has been built, the PaaS guy will buy it, and then they can actually couple things together to make a car. Whereas the SaaS guys cannot couple anything, it just comes in and say, okay, here's the money, give me the key, and then just buy a finished car. So depending on where you are in terms of expertise, you might say, because I want to cut cost and I'm a very, very good engineer, I probably would make my own car. Or you might say, okay, I don't understand how steel work, I don't understand how rubber works, but I can buy car parts, tires, steerings, and I can couple them together to make my own car. That's PaaS. Whereas SaaS comes in and say, I can't be bothered. I don't know how to wire systems. I don't know how to, fit tires into wheels. I don't know all that. I just want to buy a car, get the key, start ignition, and off I go. So that would be SaaS. But you can imagine that everything will be based on infrastructure as service because everything that if you strip a car down, it will come down to steel and cables or rubbers. That's what it comes down to. So, but you can then say, okay, depending on your knowledge, you want to operate in this at this level, you want to pay at this level, or you want to pay at this level. So we're gonna dig a little bit further. So infrastructure as service. So at infrastructure service level, you are looking at virtualized computing resource. So you're only you're talking about compute here. CPU, storage, memory, network. All the stripped down things that makes a computer. So on the cloud service, if you are looking for infrastructure as service, if that's where you want to operate, you'll be targeting solutions like EC2 on AWS. On Microsoft Azure, you'll be targeting virtual machines. Bear with me. And on Google, you'll be targeting compute engine. So essentially, you will only be looking at how to spin up a machine. So if you're kind of playing within the infrastructure service space, the people that will be able to do this will be people that understand systems, machines, and they can spin up machines, connect to it, and play with it. They will have to understand networking. They will have to understand operating system. They'll have to be happy to work on Linux. They have to be happy to work on just playing with on the operating system. It's not everybody that can do that. Because the thing is, if you understand operating systems, you can build anything on top of it. Just the same in the same way, if you understand cabling and steel, you can build a car. Okay. So if we then move to platform as service, platform as service kind of it sits on into infrastructure as service. At platform as service stage, you are leveraging the infrastructure as service, which is the EC2s, and you are kind of putting some services on them to make them usable. For example, here at EC2 level, you may have maybe created a simple machine that's just running, but infrastructure as service stage, it will be on that machine, maybe they then install a database on it, and that machine becomes the database server. The guy that is running, that is working at infrastructure as service level, who has spin up a EC2, he can easily turn this machine into a database if you want. You can turn it into a web server if you want. You can turn it into an email server if you want, because it has the bare, it's just like you are a furniture guy. You have a wood. You can turn that wood into a chair, you can turn it into a table, you can turn into a shelf, whatever. But at this stage, maybe the people that operate here want to use platform as service. They might use platform as service because they are not familiar with EC2, the bare metal, bare bone stuff, but they want to just maybe work with the database. Instead for them to create a machine and install the database themselves, no, they will leverage the cloud platform to say, I don't know how to use infrastructure as a service, but as platform as a service, I just want to use your platform. Give me a database. A database in itself is just a machine, a virtual machine, EC2 or virtual machine that is running a database software. If you were a seasoned engineer, you could have done that yourself. But you might be a developer who doesn't understand how to set up a database on a machine. But you want to use the database anyway. You will use it as a pass. So you go on the platform and you say, I need a database. So you will not be working with EC2s, but you'll be working with already prepared database. This is like going to the furniture guy and say, okay, I need some frames. So the furniture guy has created some frames. Is sandpaper them, they look good. And you say, I need some frames I can use to make a chair. And the guy gives you like 6 frames. And you can go home and knock them together to make a chair. The frames are there, you can make a chair. Maybe because you don't know how to maybe cut wood into frames because you don't have the expertise, then you will say, okay, somebody that got the expertise, do it for me. And I will just leverage that to get what I want, what I need. Let me make it more practical. So here, if you're in an EC2 word, you could have come here and say, I want to operate infrastructure as service here. And I'm going to create an instance of a machine. On that machine, I can program that machine to be a database machine. I can configure that machine to be a web server machine, and so forth. But some people might not know how to turn an EC2 into a database or a web server. They might say they need a database, but they don't know how to turn an EC2 into a database. So they will go for PaaS. Okay, in PaaS, let's go back here. Applications. To services. Okay. So let's say we need something like a database. So let's say we need like say something like I don't just want to type here, I want to show us. So I could have just typed Postgres there. Let's see, let's go back. Let's go to let's go database. So in database, what you have here, they are EC2 machines running database. So this is not just machine, but machine running a particular software. So this is what we call PaaS. These are PaaS services because they are machines running specific software. So if you're an engineer that wouldn't know how to set up your own database, you can just come here and say, okay, I need a database. I'm just going to pick one and use it. And it will just be easy, smooth database creation that will be done for you. I'm not going to create a database. I'm just showing here that you will then set up your database by simple clicks and off you go. This will be quick and this will meet your need. But whereas the guy that is more knowledgeable, who is working at sort of infrastructure service level, would have gone and create a machine and say create a machine, and on that machine he would set up, he will install the database system. It's going to be a long convoluted process, but you will be able to set up the database that he likes on his machine. And you'll be wondering, what's the advantage of that? The advantage of that would be that he can do what he likes on that machine. He can set up a version of database that he needs. He can set it up in different configuration that he wants, and so forth. And that will be different to a guy that is using existing PaaS service, because you'll be limited to what the cloud platform provides. The cloud platform might say the database that we provide is Postgres database or Aurora database of machine version 2.0. We don't offer version 2.x, but we offer version 2.y. So you're going to be limited to the version that cloud platform provides in terms of PaaS. Okay, so we move further. Let's go back here. So on the platform, so you would things like on AWS, AWS Elastic Beanstalk is a PaaS service that allows you to set up a web server, app server quite easily without having to worry about creating your machines, etc. Same goes for things like if you're on the Azure platform, you would use app service to speed up your platform management or creation. Same goes for Google you can use Google App Engine, which is sitting on infrastructure service to give you what you need in terms of PaaS. So the use case here would be that, for example, say you have you're a DevOps guy, they've given you some artifact to deploy, and say if we want you to deploy this artifact into and get them running, say let's say a website, get it running for us. So instead of you having to start clicking on creating EC2 and installing this and that, you can just leverage a PaaS platform, and then you won't have to do any installation. You just within a couple of clicks, you'll be able to set up a website. But the difference here is that you wouldn't need to do any major installation. You would just be leveraging existing service on the cloud platform to quicken your deployment. Obviously, the downside to that is you'll be limited to what the cloud platform provides. So last but not the least is software as a service. So software as a service, which is SaaS, sits on top of PaaS. So the foundation is infrastructure as a service, which is or compute. Platform as a service are specialized software running on compute. Software as a service is not a finished product, a finished application sitting on a platform. Let me give the analogy of, say you want to set up a website, okay? Say we were setting up a website, say www. Properties.com, whatever. If you were given a task and say, okay, Mr. So-and-so, which you're going to come to, we need you to help you set up a website for us. You can go in three directions. The easiest direction would be to go on a platform like Wix, a platform like WordPress, and say, okay, if off I go, I am just going to push it up there and the website begins to run. Good. If you are leveraging that, you are leveraging what we call software as a service, because the software is there. All you are doing is just getting what you need and dump it on there, and off you go. That's the easiest way, and anybody can do that. Okay. And that's the fastest way to get things to customer, get things running in production. You can also say, okay, I don't want to use WordPress because one, I don't want to be boxed into the WordPress world. And then if WordPress says they are increasing their, their service cost from X amount to Y amount, I'm just going to be stuck and I won't be able to get out. So I don't want to be boxed on WordPress. I want to have my own thing. The platform as a service that allows you to do that because all you need to do is go on your cloud provider, for example, Azure, and you take the website artifacts, the HTML, the images and whatnot, and use app service to spin up and create a website. So you will not be using WordPress, and you will not be boxed within the Wix, WordPress, or whatever. So you're going to be using App Service Engine to create your own website for yourself. So that would remove the vendor locking that you may have if you were kind of operating using WordPress or Wix or whatever. And you could have said, okay, I don't want to use AWS App Service. I don't want to use, Azure App Service. I don't want to use AWS Elastic Beanstalk, because then I will be restricted to what they provide me, in the sense that it would then mean that I'm going to have to be playing within the Azure space using App Service Engine, and I have to be paying for that service. It will be too much. I just give me a machine. I know what I'm doing. I just need a machine, and I'll do everything myself. And that will be infrastructure as service. So here you're only going to be requesting for a machine. There's nothing only on that machine. And then you get the machine. With the machine, you can then decide that, okay, I've got the machine now. I am going to install all the software I need to turn that machine into a web server. So you can then, okay, connect. So spin up an EC2, spin it up a virtual machine, and then begin to work as an engineer to prepare that machine to turn it from a humble machine into a web server. Of course, to operate at this level, you need a lot of knowledge. This is where you need most knowledge as an engineer. Here, you need knowledge, but limited. Here, you don't need much because it's just click, click, and off you go. Who this works for and why you will use it will depend on what you are after, what your knowledge level is, and the time and how much time you have to play with, and cost as well. In terms of cost, the most expensive will be this one because it's finished, it's good to go. And the least expensive will be your infrastructure service. Okay, if we summarize it, so infrastructure service, primary service, user will be admins, people that know systems. Pass will be developers. They don't really understand operating system. They don't really understand sort of OS administration, etc. But they know how to write code. And they won't know how to set up a database, but they know how to write code. But they want to use a database. So they don't have to set up their database. Developer won't have to do that. They will just look for PaaS service that offers database. And developers will leverage the PaaS service to spin up, to get their code working with a database. The HaaS guys, instead of, using an existing database, they will make their own. Developers would not know how to make a database. They know how to write code, or they will use existing database which exists as PaaS. But if you're an end user, you don't know what database is, you don't know what operating system is. You just want, like, let me just log on to WordPress and do my thing. The level of control you have here is very high because you control everything, you know everything. This is medium and this is low. Scalability, you can scale easily at this level. The one difference I'm not showing here is the knowledge requirement. You need a lot of knowledge here. The knowledge you need is not that much, and you don't really need much here. So in summary, as we give you full control over compute resources, PaaS simplify application development, and SaaS deliver complete software for an end user. This is an interview question. this is always often asked. They will say, what do you know about infrastructure service? What do you know about platform as service? What do you know about software as service? And you should be able to tell them what they are and what are those distinct differences they have. So it will be around control, about flexibility, and management responsibility. So you don't need more management responsibility as SaaS. Everything's sort of managed for you, but you probably will pay a lot, and it's not flexible because you are boxed. And on and on and on it goes. I think this will be better explained using an analogy. So let's say, again, we want to develop a website. Okay, that's why we want to host a website. So the ask guy will say, okay, I just need a machine. So you will get a machine, you rent a machine on the cloud, you spin up a VM on Azure, it's just virtual machine, on AWS EC2, you spin up a machine and you manually install all the things you need. The website software, which it might be something like Nginx or whatever, you would manually install them yourself and then you manage everything. The past guy will say, okay, I don't know how to do all that. I'm just going to leverage Google App Engine or Azure App Services or AWS Elastic Beanstalk. I'm going to use that to kind of set up my website. The SaaS person who is not a developer or an admin who's just an end user will just go on Wix, on WordPress or Squarespace, and we just set up their website there. Of course, this guy will be boxed to what these guys provide and probably will charge the person more, but everything is sort of managed for the person and so on and so forth. I hope that explains it. So we're going to kind of look at this in real life practice and see what it looks like. So I kind of have a problem definition here. So you've been tasked with deploying a website for an organization on the cloud. The necessary website artifact, including images and files, have been provided for you to use in setting up the website. So in this case, we are looking at you as a DevOps person, and we are saying, okay, somebody has contacted you and asked you to help them set up a website. You're going to be writing the code. The artifacts, the files, the images have already been provided. They're banking on you to help them set it up. So how would you approach that as a DevOps engineer? So it comes down to two things. If we go back, so as a DevOps engineer, shame on you if you are going to be doing this because an end user can easily do that. So we'll take that out. You will not be using SaaS. You'll probably be playing within PaaS and IaaS. Okay. Depending on the platform you are, right, and depending on the knowledge you have, you might say for now, because of your limited knowledge, you probably want to play within the PaaS space. So you're going to use some software platform on the cloud that can enable you to turn those artifacts into a website quickly. So for example, on Azure, you'll be using Azure App Service or maybe Google App Engine on Google Cloud or maybe AWS Elastic Beanstalk to turn those service into artifact into a website. But if you if you are a seasoned engineer and you know your stuff and you've got the time and business allows it, you might say, okay, I don't want to operate in the PaaS space. I want to operate in the IaaS space. I will not be using any of these, fancy stuff. I will just get a machine and I'm going to install everything I need. So let's see what that looks like. We're not going to be looking at this because anyone can do this. So as a DevOps engineer, we will see what PaaS looks like. We will see what IaaS looks like. So let's play with this for a bit. So let me just go here. So you've been tasked to deploy with deploying a website for an organization on the cloud. The necessary website artifact, including images and files, have been provided for you to use in setting up the site. Okay. So let's assume that the artifacts are here. So I did ask you guys to set up a GitHub account. So GitHub is a place where people keep code We're going to look at that maybe tomorrow or next week. But just for now, let's just assume that the artifact that's going to make the website are here. So you're not the one doing that. This will be provided to you as a DevOps guy. You will not be writing or developing your website. You're just going to be tasked with making it run. So they're all here. And you can look at it and say, okay, they will tell you, okay, the artifacts are available. You can go on it and make the stuff happen and deploy it and make it run as a website. Right. So please bear with me. Give me a second. Sorry, I'm back. Thank you very much. Okay, so we've got the artifact here, and then we want to put them on the cloud. So depending on your knowledge and expertise, you might say you want to sort of run this as PaaS on the platform. So let's go on AWS and look at what that would look like. Say we want to set this artifact we're given up as a website, but using PaaS service. Okay, so go here, say, okay. So one of the key PaaS services that you can use on AWS to turn simple website artifact into a running website is Microsoft Amplify. Sorry, I said AWS Amplify. Amplify. So which is this one. Okay. This is a PaaS service. With this, you don't have to worry about setting up machines or anything like that. It's just a couple of clicks and you should be able to set up a website. Bear in mind, the task you're given is to turn this into a working website. So go here and you say, okay, still kind of loading up. So this is the repo. Okay, so deploy an app. So you say deploy an app. Mm, okay. Yes. ISIS unresponsive. I'm gonna refresh it. Hmm. Just a bit slow. Anyway. And fine. Okay, so it gives you this sort of window. Um, because you're an engineer, you would need to have prior knowledge of what this is all about. So now, because you're using pass, you're not going to be creating machine, you're not going to be logging into anything. You need to just have some basic tech knowledge. So one of the things it's asking about here is the location of your artifact. So artifact as in this case would have been kept. So really the way this will happen, the developer will have created all this for you. They would have written the code and push it into a repo, which is the repo here. I'm going to share that here so you can have a look. I'm also going to show you how to copy this into your own GitHub account as well. Just bear with me. So you have that. And then all you need to do now is just say, in this case, this is GitHub. Okay, see, that's my repo. So what you then need to do is say, I want to use GitHub. And then you go next. And then you just provide the location. So you just say authorize. So it's able to connect to my account. So templates. I want to give access to a select specific repository. So specific repository. I'm going to tell you which repository I want to give you access to, which is this one. Where is it? It's this is where it is. So my repo here. Let me bring this thing down. Okay, right. Okay. So it's school portal. So I will just go and say school portal. That's the one. And I'll say install and authorize. Okay, and I will just give you access to it. You can see it's a couple of clicks, but you still need a bit of technical knowledge to know what you're doing essentially. And then this should hopefully set things up. Okay, what have we done? Add a branch. So school portal, there we go. And then in schools portal, because it's a repo, in this repo, this is GitHub, you have different branches. We're going to explain all this in coming classes. So for now, there's only one branch called main branch. Just here, it's trying to get it, and it's going to load options, and we should just be main, and then we'll say next, and then let's just finish. And then it begins to work. So we'll begin to build it up for you. I don't want you to forget the simplicity of what we are doing here, because so I expect deploying it at the point we'll be ready and I'll be good to go. I'm still kind of still deploying. So they will give you like a link, sort of like a domain name that you can use to access it, etc. And you can use that. So it says deployed. Sometimes it takes some time to kind of flush it. Well, let's just check. So TechBlake Academy, yep, it's good to go. That's it. So it's deployed there, and this is what it looks like. I just kind of conjured this together today just to demonstrate this. So we have not set up any machine, we have not done anything, but this is all running. Obviously, this is not running in thin air. It's going to be running on a machine somewhere, but we don't know because we are just using PaaS service, which is sort of making everything happen for us automatically. So the only thing we need to do, obviously, is to have knowledge of, where the repo is, what the repo name is, the branch where it's operating. And with a couple of clicks, we've been able to obviously create a working website. And then you can tell the client what website is running, is secure, blah, blah, blah. Off you go. So if you look at this website now, the couple of things you probably as a user will take for granted. There's a lock in front. That means it's a secure website. It's HTTPS. It's Hypertext Transfer Protocol secure. So that means anything that's going out across the internet on this, back and forth between your browser and this website is secure. Nobody can kind of sniff on what is being transmitted between you and this machine, which is very important. But it doesn't come to get a website to be secure. It takes a lot of work. And the work of sort of making that happen is being transparently done for you. And that is part of the things you get from using PaaS. You probably don't have the knowledge of making a website secure. You probably don't know the concept of certificates. All those things are taken, all those headache are sort of, gotten rid for you by the PaaS system, the PaaS sort of a model. You wouldn't have to worry about it. You just specify where the artifacts are, a couple of clicks, you have website running. We are going to contrast this to using infrastructure as service. And bear in mind where we're coming from is we did say that PaaS is relatively easy. We're not dealing with SaaS for now because it's just easy. Anybody can do SaaS. But we've just seen how we can use PaaS. In this case, we use AWS Amplify to turn a couple of HTML artifacts into a website. With infrastructure as service now, we are going to try to do the same, but now using infrastructure as service, no PaaS. Okay, and that will be a lot harder than using PaaS, and you'll be able to judge yourself. So we're going to attempt to achieve something close to this or use infrastructure as service. Remember that infrastructure as service only deals with compute. You spin up a machine and you roll your sleeves and you make things happen. So let's begin. Before we begin, we need to do a bit of a diagram so we kind of have an idea of what we are doing. Let me do that. Let's do draw.io so that when we begin to implement, it will make sense. Okay, we still have this. I am going to just, let me save this. Let's set this as week 1. Okay. So what we are doing next is we want to spin up a machine. This is infrastructure service. It's going to be our VM. That's the first thing we do. We'll spin up a VM. We can do it on any cloud provider. We can do it on Azure. We can do it on Google Cloud. It's just spin up a machine. So it's the same way. So when we spin up this machine, the next thing we're going to do is we are going to install a software that will turn this machine into a web server. So we will spin up a machine. We will connect to it. We will install a software that will turn into a web server. In this case, we just install Nginx. Okay. And after that, you would then need to find a way to get this artifact, which is on the repo here, onto the machine. Okay. So first thing first, so let's list this task out. Put it here. Oh no, it doesn't like it. Okay, do your thing. Okay, cool. Don't worry about this. I just want to use this to kind of list what we want to do. This is my machine. This is not cloud or anything. This is just my own my Mac machine. So let's talk about steps. Let's do Vim steps. Steps. The first step number 1, is spin up a VM. Spin up a VM. The next step will be to connect to the VM. Number 3 will be to install web server software on the VM. This turns the VM to a web server. Number 4, install Git software on the machine, on the VM, to download the artifact. Download, use Git to download artifact to the web server HTML directory. Start or restart web server. Open port 80, HTTP. Test to check or ensure website is up. So this is like the rough steps. I'm going to just cut these. So we'll see. This is from my machine. I'm just This is on my machine. So these are the steps. So we'll spin up a VM, we'll connect to the VM, we'll install web server software on the VM. So let's do the first two steps. Let's spin up a VM, let's connect to the VM. So this is the diagram. This is the VM. On this VM, we want to, so we are here. We are here from our home. We'll connect to the cloud. And then from the cloud, we'll install this VM. So this is me here now. I would then connect to the AWS cloud, AWS. I'll go here. Okay, but we are not dealing with PaaS. Now we want to use infrastructure service as. So go to all services and we can just do EC2, go compute. If you can find it, EC2 should be there. There's nothing stopping you from going on Azure as well and just clicking on a virtual machine. It's the same thing. So here we say launch instance. So let's call it a web server, web server, web server. We're going to call it that. We're just going to check this, Amazon Linux. We're just going to make everything sort of default. T3 micro, that's all right. I'm going to, I think I already have a key I created last week. I can use that key. If you don't have a key, you can create a key and then just leave it like that. The one thing we would do here is because when we set this up, we are the engineers setting it up. The people that will use it, they're somewhere else. It's going to be you in Nigeria, you in America, you in the UK. You are coming over the cloud as well. And then trying to access the website here. I am the sort of the DevOps guy doing the configuration to connect to the machine because I'm going to be doing the major work. I'm going to be coming through the main gate that gives me access to the VM to do anything. So I'm going to be coming through what we call port 22, like gate 22. Gate 22 will give me access to everything on this machine. But you will be coming through gate 80 because you only want to access the website running on this machine. Installation, compute, SSH, LS, that is none of your worries. Your business is just to use the website. You don't even know if it's running on a Linux or Windows. Like you don't need to know because you just want to use a website. You don't even need to know that's running on a machine. But that website is running on a machine, and to access it, you have to come through port 80. So that port, that gate must be open. If it's not open, you will not be able to access it. So when I'm setting this machine up, I have to make sure port gate 22 is open and gate 80 is open. And this is what it is saying here. So SSH, and that is gate 22. Gate 22 is SSH, and HTTP is gate 80. So this SSH is this gate. And so this is, you can call this the SSH gate. And this is the HTTP gate. Okay, so those gates have to be open while you're setting up the system. So you say allow anyone to come in through SSH, but you need to have a key to get in there. But port 80, did allow traffic from allow internet traffic from port 80. So it's traffic. So this is what allow this, checking this box then allows these guys to come in through this. Otherwise, this would not be open and they will not be they'll be able to access. You have to check that, it's very important. And then you spin up the machine. So this is creating ours, which is just a VM. It's just compute, nothing else. On this, what you have on this machine is just memory, CPU, and storage, nothing else. So let's try and connect. So connect. It's ready. Okay, the machine is ready. You can say uptime. How long has it been running for? It's been running for just 0 minutes. It just literally just came up. Okay. Uh, Now, let's say everything was sort of set up on this machine. We've done all the work we need to do, which we haven't. Let's just assume for once that for now that it was done. The way we would have accessed this machine as an end user, not as an engineer, as an end user, would be it would have just got the machine name, which is the public name, which is the public name. This is the name we would have used to access. It would have just gone on the browser, which I will give to you now. You just put this on your browser. You just say HTTP dot, and you select it. And this is how it should work when it's all done. But it will fail now because we have not set it up. I'm going to share that now just so that we have it to hand. Now you can try. You will see that for now it wouldn't work. Okay, we'll put that here. You can give that a shot. Click on it. It will not respond because even though the machine is listening on that port, there's nothing to serve on that port. There's nothing working on that port. So the gate is open because the machine is running. This gate is open, this gate, but there's no party happening here. The gate is open, but it's empty. There's nothing running there. And that is how when you hit this, it doesn't do anything. It's not that it's timing out. It's just because it's like you're going to a party and the party has not started. So you just be quiet. So we need to get a party started. So what we need to do is, according to our steps, so we spin up the VM. We've connected to the VM, which is this is the connection. We are connected. If you check uptime now, I think it's been running for 2 minutes. Okay. That doesn't matter. It's just me showing how to use the uptime to get the machine status. So now install the software, install a web server software on the VM. This turns the VM into a web server. So what am I saying there? So this is just a humble VM. It does nothing. But this VM is just a machine. You can turn this machine to a web server. And I'm just going to pause here. The statement I just made is a very big statement. Why is it so? This VM, okay, it is just an operating system. Of course, it's running on AWS. This may as well be running on Azure or Google. It doesn't matter because it's just a Linux VM. This could have been your what's it called? A micro device such as your microcontrollers. The name escapes me now. That you could have bought and kept somewhere and running your home. So a little machine in your house or a little what the name just escapes me. It's gonna come to me. That thing is there's a little machine that you buy. You can turn it to a web server because all you need to do is to put the right software on it, and it will turn any machine into anything you want. For example, your TV there's a software put on your TV that turns it into that TV packet that you see. The Amazon Echo you use at home is running an operating system. So you can turn any machine into anything you want. It comes down to the software running on the machine. So in this case now, this humble machine, we could have turned this into an email server. We could have turned into like a file server. We could have turned into like a video server, but we choose to make it a web server. And what makes it a web server is just simple installation. We just say sudo yum install. We are just installing install um Nginx. Now I'm saying sudo and I'm saying yum. I'm just going to pause and explain this a little bit. So the yum is a package manager on this operating system that allows you to do installation, uninstallation, or removal or update of software. So this yum is a package manager which you can use to install or remove an application or configure an application or update an application on this system. The application in question for now is Nginx, which is the web server software. This is the software that will turn this machine into a web server. The sudo means that because it's a very serious operation that we want to run, you have to run it as an admin on the machine. You can't just run it as an ordinary user. If you run it as an ordinary user, the system will not allow you because it's an operation that could change the profile of the system. So you have to use sudo. That will say that I want to run this as an admin. If you don't put sudo, if you try to run it, it won't work. It will say you don't have the permission to do an installation. You have to be a super user to be able to do that. So with sudo now, by the way, currently now on the system, if you do ID, who are you? What's my identity? You are EC2 user. Okay, you are not an administrator, but you're an EC2 user, but you belong to the admin group. So you can potentially use admin privileges to do what you want to do, but you are not really an administrator, but you belong to the admin group. And you can use some admin privileges because they allowed you to leverage sudo to do some admin tasks. So IT is quite important to obviously always check your identity on the system. So if you then say sudo yum install nginx, and I'll begin the installation for you. So because we are using a very not so strong system, it will take a while, but it should be able to do the job. Now this is all installed. Okay, if we check again here, it still won't work. Nothing works here yet because the party has not started, but we've installed this software that will turn into a web server. So what we need to do next is to start it. We can say sudo service nginx start. Okay, now this is started. Now this then begins to respond now because we've got the service running. You can see it's listening, it's doing something now. Of course, it's not showing us this beautiful stuff that we have with this Technic Academy, but now at least it's responding. Now the machine is no longer a machine, it's a web server now. And then if I stop the service, obviously it won't work anymore. So this will just fail. And then you won't be able to, I think it's cached it. My browser's cached it. But if you do a hard refresh, it shouldn't work. So, but I can bring it back up and say start. See that? And then it's working again. Of course, it's not giving us what we need, but at least, this machine is no longer an ordinary machine, it's a web server. One thing I want to show you here is, as we kind of embark on our Linux journey, is currently there are two that I am to use on this machine. I cannot be using sudo this, sudo that, sudo. I can basically switch my identity from EC2 to a root user. But what that means is instead of borrowing root privileges, which is super admin privileges to do what I have to do, I can become that super admin myself. So I won't have to use sudo this, sudo that. It's like you're saying, excuse me, sir, can I do this? Excuse me, sir, can I do this? You can actually become that sir yourself and switch. So you won't have to say, excuse me again. But this is, excuse me, sir, can I run this? Excuse me, sir, can I do this? But you can actually become that sir by doing sudo minus I, and then you have become root. You see that? Now you've become the sir. So with that sir, you don't have to do anything. You can just say service, nginx, stop. You won't have to do sudo anything again. It's just boom, boom, boom. This is not encouraged, but I'm just showing you, and we will explain all this, as we kind of go along. And in most cases, when you're working for a company, they will not give you root access because that's like the top level access on the machine. But because we play with the machine now, you might as well have it and see what it's about. Okay, we're gonna start the service back, and then we can check where we are. This is we're in root directory, blah. Okay. The next thing we want to do, so just leave it like that. Next thing we want to do is let's see. Where is the steps? So we have now installed the software. It's done without the next thing. The next thing we want to do, of course, we want to install Git software on the VM to download the artifact. What do we mean? So now this is sort of working Nginx, showing us that it's a working web server, but it is not giving us this end product. Why is that? Because the artifact that is showing, which is what is making this website what the way it should be, the artifact is in Git somewhere. We need to find a way to get this artifact onto the VM. So if you go to the little diagram we have, the artifact is sitting in a bucket somewhere. So if we find a bucket, I just use a diagram to represent it. Let's see, bucket. Yeah. So our GitHub. This is where the artifact is. The HTMLs are all here. So we got the GitHub HTMLs. So this GitHub tech, this is GitHub template. Which is this guy here. So what we need is, this is it, which is, go to the little diagram. Where is the diagram? Here. Just kind of get this. Okay, so this is the get location, GitHub location. So we will have to find a way to download on this machine. So all those artifacts will just come down here. And we'll put in the right place so that the VM, so the Nginx, which is now running here, Nginx, which is now running here, can then use this artifact to kind of make the website look like this. Currently, it looks like this because it doesn't have the artifact. So going back with the diagram, so we need to find a way to download this artifact onto the Nginx. So to download this is it's not like just click download. You need to get the right tool that will help you download. That tool is called Git. GitHub is the location where the file is. The tool you're going to need to download the artifact, the material from GitHub is called Git. So you have to install that software or the app on your VM to be able to do that. So we don't say again yum. Now you can see I'm not doing sudo because I'm still root. Install Git. And I'm just going to install it. And then I'll say yes. And then Git is installed. Now with Git installed, I'm almost there. So What do I mean? For example, let me show you something. Let me go to a temp location on the system. I'm going to go to a temp directory on the system. It's just a temporary location. Let me make a directory in temp. Where am I? PWD. I'm in temp. I just want to play about, do something. Before I go any further, let me type the git command. You just see git, and you see that git is on the machine now. It's ready to work, but I'm not telling it to do anything. I just type git just to make sure that the git command runs and is installed correctly. It's there. So what I can do is I can make a directory. I can just call it workspace. Let's just call it that. I'm going to cd to workspace. I'm in workspace now in temp. Yeah. I can decide to pull this content from here into the machine here. Okay, so how do I do that? So what I need to do is I can see this is the location, right? So what you need to do is go to that location and then you say code and you go HTTP and then you copy this. So you want to clone this repo. That's what it means. Code, clone, but make sure you say HTTP and then you copy this and then you bring it into the VM, and then you say git clone. I want to clone this location. That's what it means. So before we do that, let's ls. There's nothing in this space. We just created it. If we now say git clone, it's like you're downloading. Then you clone, and then it's done. And then you say ls. Then you have a little directory called school portal. Then you can cd to it. Then you have a little directory called school portal. And then within school portal, ls, you have those about, contact, blah, 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 blah. PWD, you see where we are? When the directory are created, temps, workspace, school portal, and so forth. But this doesn't change anything because we are just downloading from the from GitHub into the repo. So if you go by the diagram we have, what we've done is we've done the download into a little space on the VM. So a little space on the VM. So if we just use another diagram, it's a little space on the VM. Time, workspace, blah, blah, blah. / something. And in that location, we've downloaded the code there from there using Git. You can see the level of what we have to do to use infrastructure as service as opposed to just one click using pass. And we're still not there yet. Okay, we are just 1 or 2 steps away. So now the artifact lives on the machine, but you need to point it to a location where Nginx can see it. So what do I mean? So currently here, where are we? We're here, and the artifact is all sitting here nicely. But the artifact cannot live here. It needs to live in a location called user share Nginx HTML. That's the location where anything that you want to share with the web server should be. All these artifacts cannot be here. They need to be in a location called Nginx HTML. That location is this location. Let me just LSE for you. So the location is USR, share, Nginx, Nginx HTML. That's the location where those things should be kept. So we'll have to copy. So it is this location that we have to target and copy everything we have in current directory, which is ls-ltr. everything here should be copied here. Everything in this location, where are we? Everything here should be copied here. So how do we do that? We're going to issue copy command. We are in the current directory where the artifacts are. So everything in this location, cp, copy everything, including directories, including folders, -r. Okay, cp, copy everything. So we say cp -r star, or should be copied to this location. Copy, including directories, not just files. Everything from here, that is what it means, star, to that location. Why are we doing that? We're doing that because, of course, the files have landed, but they have not landed. It's like you are going to, say, you are going to National Stadium, Surulere, but you've landed at the airport. But the airport is not your destination. Of course, it takes a lot of work to land at the airport, but that's fine. But you need one more step. You need to just get a taxi and go from Motala in Ikeja to Surulere. So that's the last step. Otherwise, you're still not going to be at the party. So the files have landed here, but that is not their target location. They need to make it to here. That's where they're going to be seen. So copy, including directories. If you don't specify the R, if it's just going to copy the files, it will not copy these directories, this image SSS minus everything, star, there. And then we do that. Boom. Yes, overwrite, yes. And then it's done. So everything has been copied. If we've done it where we may not need to restart, so let's check. And then voila, see that? And that's it. So we have now turned a humble VM into a web server. So if we go, so what we've done is now copy those files into Nginx somewhere. Okay, just copy the file into Nginx. And then these guys are now able to see it. So the files made it from there to the machine workspace. We then copied it into here. A nice little step would have been also, what I could have done also, I could have just git clone directly into that location, but that would have made it not easy to explain. That's why I just created a little directory, created a little directory here, and then do a git clone to that directory, yeah. And then I then did the copy, which is this one. And then this is the magic directory where it should go. It goes in that directory, then Bob is your uncle. He will just work. So I think this is a good place to stop, because what I want to do next is I want to go to the next stage of manipulations of the platform and not the rest of it. But I think for now, the concept of PaaS, infrastructure service, performance service, and software service was what I wanted to explain and actually see it in practice. And this is what hopefully I've been able to do. So as an engineer, you would have maybe used Elastic Beanstalk or Amplify or their variant in Azure or Google to do your PaaS, which is what we did here. And you could have used EC2 or virtual machine to achieve the same thing. If you are like in the SaaS world, you probably would have gone to Wix.com and then just use their simple platform to achieve this. Now, this will be the quickest, but this will be using SaaS. Okay, and anyone can do this. You don't have to be a DevOps engineer to use Wix. But if you are if you want to play in the SaaS space, PaaS space on IaaS space, then you need some knowledge. You can see how much effort it took to turn this machine into something beautiful. not that one, into this. Now, if you want to practice this on your own, the first thing you need to do is you go to the link I gave to you, and then you say you want to just fork it. That means you want to copy this into your own space. You can easily do that. You just click. I think somebody's at one person has done it already. Who's that smart dude? So you just come here and just click fork, and then that person, you can just copy it into your own space. So you won't have to play with my own space, and this will just copy into your own GitHub account. Blah, 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 blah. Okay, anyway. So please do that. Click on fork and then into your own space, and then click so that you won't have to come to my space. But it doesn't matter if you come to my space. And you can just, if you want to follow the class, you can even use my space and just code HTTP, copy the link. Let me share it. Oh, Raspberry. Thank you. That's what I was trying to remember. Raspberry Pi. Thank you, Tammy. So Raspberry Pi, which is a very simple device. You can turn it into a web server by installing Nginx on it, and then you can run it. You can run your company website, your own little website on a simple Raspberry running in your bedroom. Because all you need to do is just deploy Nginx on it, and Bob is your uncle, and then just install it, set it up, and off you go. Maybe one of these days, one of our hackathon, I might show you how to do that. Right. Okay. Thank you very much. Does anyone have any questions or comment before we close the class? Tomorrow we're going to be looking at version control using Git. We're just going to continue with this example, and I'm just going to use that to introduce version control. So that's what we're going to look at tomorrow. If you can just copy this into your own space, just do a fork and try at least have it in your own space. That would be good before tomorrow. But it doesn't matter if you don't do it. It's all good. Any questions or comment before we wrap up? Okie dokie. All right then. Thanks, guys. Thank you. Have a good one. I will meet again tomorrow. God bless.
Questions.
Oh, Adebayo, yes, go for it.
Yes, sir. Thank you for the lesson. I really appreciate it. Sir, I want to ask, what if the web app want to upload as its own database? Like we have to connect to the database. How will we do that?
Okay, so the way you do that, that's a good question, Adebayo. Yes, I got the question. Thank you. The way you do that is it's the same thing. So say you have the machine sort of running now, just doing all that. You can then work with the machine with the app configuration. Maybe it needs to connect to a database. You can then go and spin up that database, maybe as a VM. Maybe you start up the database yourself again, just create another VM, install a database. Okay, so it could just be a simple case of, oh, what database does it run? Oh, let me create let's call it database. So if you are like, if you want to do database as, sorry, if you want to do that database as maybe so you are saying that this is what, let me show what Adebayo is asking. So we've got a VM, okay, it's all good, it's running. Or he's saying that what if that website needs a database to run? Maybe it needs a database to run. Maybe where it's gonna keep like maybe some listing of this academy, maybe student, the upcoming events, where is it getting this from, blah, blah, blah. Maybe it needs a database. Okay, where did the information will be kept? Maybe that's how they've designed it. Maybe if that was the case. Okay, so let's kind of put that in the diagram a little bit. So we're saying that this VM might need a database. Okay. So now we can then look at the database. We need to provide a database for the VM, for the app. We can look at it in two ways. We can look at the database as and infrastructure as service as platform as service. Okay. If it was infrastructure as service, if it was platform as service, we just set it up. We're just going to go here and say database. Where is it? And what kind of database is it? This is just relational database system. We click on it. The same way we kind of created that website using a couple of clicks. With a couple of clicks, you can create a database, and you won't have to worry about setting it up. You just click, 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 it's done. And you can provide that database configuration to your machine. And this will be using parse because you are clicking, clicking, and creating your database. Conversely, you can just go VM. Obviously, this is not very common. People will just use database as a pass. They will not create their own database because database is quite tricky to do. But if it was simple enough, you can create your own and just say launch instance. And then you say you call you call it your database. What makes a machine a database is the software running on it. So database, and then you specify maybe you want it to be stronger than T2. Okay, T2. Okay, the T2, T3 micro should be fine. And then you select that, master. And then the database, probably depending on the kind of database you want to run, you need to know the port where it should run. I think if it was MySQL, I think it probably run on, I don't remember now, 5 something something. I don't remember the port, 3311 something. You specify the port, and then you launch it. When it starts, it's just going to be another VM. So what we are saying now here, if you look at the diagram here, you are now saying you don't want that. What you want is another VM. That is now running. You're going to install a database on it. You're going to install a DB. And this is your VM. Let's move this up. And this is your VM. So let's say this is running now, and obviously they can then connect. So if you go instance, so is that going to be our second instance now? So we go by instances. Excuse me. So we have the web server running, and then we can connect to the database server. Obviously, it's not a database server now because it's not running any database software on it, but you can connect to it. And then it's not typing. Okay. Right. All right. So all we need to do here is very simple. So we can just become root. Let's become root. Now we don't have to say sudo this, sudo that. So we can just say yum install. I think it will be MySQL server, MySQL server. That's all you need to do. Of course, it might stress the system because the system is not powerful enough. But this is the theory of it at least. Till MySQL. Let's do yum search. Let's search for it first. Okay, we see. Okay, it doesn't go. I think it's Maria. Blah, 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 blah. Let's do this one. Let's do this one. So we'll say yum install that. And then off you go. And that's it. And I can say service Maria DB. Maria can type Maria DB, I think. Start Maria DB server, something like that. Okay. Maria DB server. Yeah. So we can look at this, but this is the theory of it. Does that make sense? And then this then turns this into a database server. So, and then this will begin to work, and then you can configure this to connect to that. In fact, you can also install, if you want to do the WordPress, you can install WordPress on this machine and configure it on your own. So you can use a WordPress configured by yourself from scratch. Does that answer your question?
Yes, sir. Thank you, sir.
All right, cool. Any other questions before we wrap up?
Yes, just a quick one. I've noticed that, or let me say, based on the course of my knowledge and this thing, I've realized that it's always women's name they are using. Maria DB.
Okay,
Andra.
Kule, please, what's the question? What's the question?
Why don't we have James?
Okay, so that's just, let's not worry about that too much. Let's kind of, yeah, let's allow that to pass. I don't know. It's just what we use. Any other question? All right, gents, thank you very much. We'll meet again tomorrow. Have a good one. God bless.
Thank you. Bye.
Any assignment before tomorrow?
Thank you.